Section 1.4, surface area of right pyramids and right cones. Right pyramids and right cones. Okay? So let's talk about right pyramids and right cones here for a bit. First of all, when a geometric figure is a right figure, so this right here is right, it means there's a right angle involved. Okay? And if you have a three-dimensional figure like a right pyramid or a right cone, the right angle is between the base, okay, and the top point or the kind of vertical position. So what I'm going to do is I'm going to draw for you a right square pyramid. Now you may not be very good at drawing three-dimensional figures, okay? Usually in grade 10, most of you just like your figures look really funny. It's okay. Don't worry about it. You're going to get better at it. Let me show you some tips, okay, to drawing good three-dimensional figures in math. Okay, we're going to draw the base. Draw this line straight across, horizontal. Draw this line to one side at some angle, doesn't matter. Okay? This now, don't make this one quite as long as your front one, because it's going to be three-dimensional, so it's kind of like going, this side right here is the same length, but it's kind of going back into the distance, so you don't want to make it quite as long. Okay? So let's also do this from the center of what would be this square, and I'm not drawing those other sides yet for a reason, but straight up in making a right angle with the base, straight up, somewhere up here, put another point. This is going to represent the top of the pyramid. And a pyramid, of course, has, triangular faces to it on the side. All right, so you make this line, you make this line. Now connect the top with this corner. The same over here to this corner. And then over there to that corner. So it's actually pretty tough to do on this tablet, I apologize. But okay, so see that? Now this is sort of the middle of the base. Now the reason why I didn't put those other sides in there is because what I'm going to do is, because those sides are hidden from view from the front of this pyramid, I'm going to make them dotted. Now, see this side right here? This other side needs to be the same length and the same angle. It needs to be parallel. So let's give it a try. Go like this. Dotted, the same length, and parallel with this side. Everybody got that? Now, this back side over here needs to be parallel with the front side and also dotted because it is out of view. And it should meet up exactly with this point there. So you see how we've completed the rest of that base there? The one final thing you need to do is to go from this point down to this corner, but make that a dotted line as well. Because technically it's behind view. We can't really see that from the front if this was a solid 3D figure. Okay, so the base is a square. And you know this because of this little notation right here. Okay, you have a line there and a line here. That means that these sides are the same length. Okay, because these lines are parallel, right? And these lines are parallel. We have, we have a square there. I know this isn't a 90-degree angle, but really, this would be a 90-degree angle. See, it's just kind of flattened. All right. So this is a square base. So this is a right square. Whoa. Pyramid. And where's that right angle again? Well, it's actually right here. From this point in the middle of the base up to the top point, which is called the apex. That's the highest point in this figure, the apex. And forming a right angle with any side. Okay, so this is a right angle. This would be a right angle. Okay, so see how it's starting to look three-dimensional now? Okay? That's a right square pyramid. Questions? So these side lengths are the same on all sides, front and back, and side to side. These would be the same as well. Now, they might not be the same length as the sides of the square, but they would be equal to each other. And the faces here, the triangular faces on the side, so here's one of the faces on the side there. These would all be the same shape and same size. Okay? So triangular faces. The height of one of the triangular faces, let me use a different color here for you, and you would draw that by connecting the midpoint of one of the sides with the top, with the apex. This right here is called the, and your diagram may be getting pretty busy here right now, so I apologize, you might have to make a bigger one later, but this is called the slant height. That's the slant height. And if we're talking about just the height of the figure, that's this height right here. So there's a difference between the height of the pyramid, that's from the base to the apex, and the slant height. That's from the midpoint of one of the sides to the apex, okay? Any questions? Let's talk about other right pyramids then, like a right. Let's do a triangular base pyramid. Okay, so what we're going to do is we're going to draw a triangle, but a kind of a flattened triangle. Okay, so again, we're going to draw something three-dimensional. Draw a triangle that's kind of squished down, not a two-dimensional, triangle like this, but sort of a flattened one. And we're going to say that these are all the same length, even though, it doesn't quite look like that. But we're going to say they're all the same length because these sides are kind of coming out towards us, okay, in the horizontal plane here. So let's put a point in the middle of this base, and perpendicular with this side right here, let's go straight up, and we'll put a point just up there. All right? And we'll connect the point to this corner over here, and to this corner down here, and to this corner over here. Yeah, that one is that. That's the toughest for me on this drawing utensil here. Boom. Okay. So this, okay, if this is a right angle that's formed with the height here and any one of the sides, right? It's a right angle. This is going to be a right triangular pyramid. So right is this 90-degree angle. It's formed the height, to the midpoint of the base. This part here, triangular, is the shape of the base, and the pyramid obviously meets at one point. Okay. This, you don't have to draw this, but this is not a pyramid, is it? That doesn't look like a pyramid, and that is not a pyramid because it doesn't meet at one point. Do you know what this one's called? It's another P word, but prism. Yes, this is a right triangular prism. So here we go. This would still technically be right if that's a 90-degree angle. This would be a right triangular prism. Okay, I think that will come later. We're just kind of focusing on pyramids for now. All right. Okay, take a moment right now, and if you can, I want you to copy down from your textbook, draw in your notebook, see how good you are at this now, the right pentagonal pyramid. The right pentagonal pyramid. I'll let you find it. pentagonal pyramid. Okay, so we'll see what your drawings look like. Just make sure your base has 5 sides, that it's a pentagon. And we're going to kind of squish it as we draw it so that it looks more three-dimensional, right? You don't want to draw, a pentagon kind of like this. That's nice and, regular, because then if you put a point up here, it's like that's really kind of skewed, right? It's like, whoa, that's kind of weird. But if you flatten that out, it looks more like a actual three-dimensional figure. And you can say this is a regular pentagon by just making these marks here. And even though it might not look to scale, that means that they're all the same length. So this is a right because, well, as good a drawing as I can make you, I guess. That's a right angle there. From the apex down to the center to the midpoint of one of the sides, right angle. Right pentagonal pyramid. So if we talk about a right square pyramid, and of course this, we're going to talk about cones later, okay? But remember, we're talking about surface area. And if we're trying to calculate surface area, and I think you guys would have done this in grade 9 math, correct? You guys remember doing this? So this is pretty old school, I guess, for you. Except maybe, did you do pyramids? Do you remember? Pyramids and cones and... You think so? Maybe? Okay. All right. Well, we'll see what you remember. Okay, surface area. Area is the amount of space that a closed figure covers. So if we're talking about the surface area, we're talking about all of the exposed, area on this figure. Wow, didn't mean to erase that. So it's all of the sides of the figure, all of the area of all of the sides added together. Okay? So it might be helpful for us to think about these diagrams as a net diagram. Do you guys remember net diagrams from grade 9? Okay. Now, net diagrams take a little bit of spatial awareness and thinking. What you're doing is you're unfolding the shape, and you're flattening out all of the sides so that they're on the paper. So a net diagram of this, okay, not necessarily to scale here, but okay, you'd have a square base. So this is where now we're not drawing three-dimensional with the slanted edges, right? We're drawing now two-dimensional. We're basically unpeeling. We're cutting the edges here, and we're unpeeling these sides down like that. Okay, that one's coming down there, and so on. And so we have the sides. The 4 sides are triangles. Okay? And so this is a net diagram. And it's really helpful for most students to envision this as 1, 2, 3, 4, 5 different two-dimensional figures that you got to calculate the area for. Okay? Not 100% necessary. Maybe you get to a point where you don't need to draw the net, you don't need to visualize the net, but it helps you make fewer mistakes. And again, I need you guys to understand that in math, and you guys are still young yet, but you need to understand that showing your work, okay, is a necessary thing for you to ensure that you don't make as many mistakes. Okay? So when I say, hey, show your work, communicate to me what you're doing, make sure you got your units, make sure, cross your T's, dot your I's. When I do that as a teacher, I am trying to help you learn how to work and make very few mistakes. That's my goal. Okay? So when you say, oh, I need to show my work, it's my calculator, oh, I see this in my head, how'd you do it? I don't know, I just got the right answer, don't bug me. Okay, if that happens, I just want you to know that I'm on your side, okay? Because I'm envisioning for you AP Calculus down the road, okay? And when you're doing one problem, that takes up 2 full pages, and you have to make every step count and make sure that you copy everything right, and you show your work, and you don't miss one single negative sign. This is what I'm envisioning for you, okay? This stuff is easy. It's going to be easy for you, for some of you. But it's going to get harder. So I want you to be good math students, okay? Just a little aside there. So when you draw a net, you think of it as, hey, this is going to be easy for me to not make any mistakes when I do this, okay? And that's your goal. All right, so let's actually calculate the surface area. Let's say that this is 5 units here. So 5 units by 5 units. On your net diagram, that translates